So for this right here, um, this right here is what we call the slope-intercept form, right? This is the slope-intercept form, but there's another form that we call the standard form. So the standard form, we can redo this standard form by making it look like ax plus by equals c. So what I'm going to do is I'm going to put the x and y on one side of the equation and then the constant on the other. So if I multiply everything by 2, 2 times y is 2. This 2 cancels with this 2. So I get negative 25 times x. And then, so that's that one. And then if I multiply this by 100, I get positive 200. Then what I'm going to do is I'm going to add 25x. Oh, this is 2y. So then I'm going to add 25x to both sides. 25x is not a like term with 2y. So that just becomes, and I'll write this over here, 25x plus 2y equals 200. So this is called the standard form or general form. I can't remember. There's standard and general form, but anyways, that's one way to write it. And the other way to write it is in purple. So that's one variation of it. And then the slope-intercept form, and these terms are important because this is what's going to be on the SAT. This is the part that you need to learn. Mr. Adams isn't using the fancy vocabulary words just to impress myself. This is how it's worded on the SAT. Is this one right here, which is negative 25 over 2x plus 100. We like the slope-intercept form because we could graph it. In other words, if I come here and I put my y-intercept at 100, if I go down 25 and over 2, I'm on the graph. Does that make sense? Actually, it's more like this. If I go down 25 and over 2, I'm on the graph. If I go down 25 and go over 2, I'm on the graph. If I go down 25 and over 2, I'm on the graph. So that's what the slope does for me. Why is it negative? Because it's downhill. So those are all the connections that we need to make. You have a graph that goes downhill, so the slope should be negative, right? When we do all the math, the slope is negative, right? And there's two different ways to represent the graph. If I plug this in a graphing calculator, I'm going to get the same answer no matter how I graph it. So let me just show you that real quick so you can believe me. If I go into Desmos, which is a graphing calculator, if I type in 25x plus 2y equals 100, that's the graph I get. Or, no, I'm sorry, equals 200. That's the graph I get. And so guess what? If I pull this out, it's the exact same graph that I've graphed. The scale's a little different. But now if I go in here and I say y equals negative 25 divided by 2 times x, times x plus 100, they're the exact same graph, okay?